Welcome to all. In this lecture, we will learn how to add two polynomials which are represented using a linked list. In the previous lecture, we have learned how to represent a polynomial using linked list. Adding the terms of a polynomial means that we are comparing the terms of the polynomial and we are combining the like terms. Take one example. We have two polynomials. The first polynomial is 3x square plus 2x plus 1 and the second polynomial is 5x square minus x plus 2. In this case, we have three terms for each of the polynomial. Now, after the addition, we compare the first term of the first polynomial with the first term of the second polynomial. We observe that both are having x square, so they are like terms. Then we must add their coefficients. So we will get the answer as 8x raised to 2. Take the second term, so they are also like terms, so we must add them. Adding the coefficients, we get 2 plus 1, 2 minus 1, 2x and minus x. So the result will have x. The third term is 1x raised to 0 and 2x raised to 0. So they are also like terms. So we write it as 3. That is 1 plus 3. This is how we add two polynomials. If you observe, you can understand that all these polynomials are represented in the decreasing order of their exponents. In this case, while we are comparing these terms, it is easier for us if the terms are arranged in the decreasing order of their exponents. Otherwise, suppose that if 5x square was in the third position in the second polynomial, for comparing it with 3x square, we will have to traverse the second polynomial until the end to find where 5x square is there. It is a time consuming thing. The idea of data structure is all about organizing data in such a way that we can do operations on them in the most efficient way. So, organize the polynomial such that we can perform the addition in the most efficient way. So, we organize the polynomial such that they are ordered, each term is ordered in the descending order of their exponents. Now consider an example. 5x raised to 6 plus 6x raised to 4 plus 2x cube is the first polynomial and 8x raised to 6 plus 3x square plus 4x plus 5 be the second polynomial. Now let's represent the above polynomial using linked list. Poly 1, it is used to represent the first polynomial. While representing a polynomial using linked list, we represent each term of the polynomial using each node of the linked list. In the first polynomial, there are three terms. So, we require three nodes. In each node, we store the coefficient value, exponent value and link to the next node. So this is the first node of our polynomial which contains the data about the first term of the polynomial. So this is for 5x raised to 6. Pointer head 1 points to the first node of the first polynomial. The second term is 6x raised to 4. It is stored in the node as shown here. The third term is 2x raised to 3. So we use one node where the coefficient value is 2, exponent value is 3. Similarly, for the second polynomial, we store the 4 terms of the second polynomial using 4 nodes in a linked list. Head 2 is a pointer to the first node of the second linked list or the second polynomial. The terms are 8x raised to 6, 3x square, 4x raised to 1 and 5x raised to 0. It is represented as given in the figure. Now, how do we perform the addition? For that, we have to compare the terms of the polynomials. First, I compare with the first term of the first polynomial with the first term of the second polynomial. There, both are having x raised to 6. So, we need to add those coefficients. So, we will get 13x raised to 6 as the result. Now, as we have processed both the terms, we can move the pointer to the next terms of the linked list. Okay, so we will compare 6x raised to 4 with 3x square next. Then we notice that these are not like terms. One is x raised to 4, other is x raised to 2. Then what we will do? We will write the term with the highest coefficient value to the resultant. Why? Because we need to keep that order of descending order of coefficients. So we write 6x raised to 4 to the result. Then that pointer will be moved to the next term of the polynomial. Then we compare 2x cube with the 3x square. Which one is greater? 2x cube. So we will write 2x cube to the resultant next. After that, we understand that the first polynomial has completed. Then write down all the remaining terms of the remaining polynomial to the resultant. So we will write down 3x square to the result, then 4x to the result, then 5 to the result. So our final result is 13x raised to 6 plus 6x raised to 4 plus 2x cube plus 3x raised to 2 plus 4x plus 5. So here we have represented the two polynomials using two linked lists. Head 1 points to the first node of the first polynomial. Head 2 points to the first node of the second polynomial. We use dummy pointer ptr1. It is used to traverse through the polynomial 1. And another dummy pointer ptr2 is made. It is used to traverse through the second polynomial. Why are we using extra dummy pointers to traverse? It is because if you are traversing using head 1 or head 2, we will lose the information. Where is the first node located? While we move on to the next nodes. In a singly linked list, there is no provision to come back. So it is essential to make another dummy pointer to traverse through the singly linked list. So what are the statements to make this pointer 1? That is ptr1 is equal to head 1, ptr2 is equal to head 2. After that, at present ptr1 and ptr2 points to the first nodes of both the polynomials. Then at this point we compare the exponent fields. If they are equal, we will add the coefficients and write the exponent as it is. So in this case, the exponent fields are same. The value is 6. So we will add 5 and 8. We will get 13. We will create a new node and we will insert that new node to the result polynomial. And then increment the pointer ptr1 to the next node, or shift the pointer ptr1 to the next node. Once we have processed a node, shift the pointer to the next node. Then shift ptr2 to the next node. Now ptr1 and ptr2 stands at the next nodes. Compare these nodes. So one is having exponent 4, other one is having exponent 2. These are not like terms. Then we will write the term with highest exponent to the resultant. Then we will write 6x raised to 4 to the resultant and shift ptr1 to the next node, while we will not change ptr2. It will stand there itself because we haven't yet processed that node. Okay, we have shifted ptr1 to the next node. Now compare these two nodes, PTR1 and the one pointed by PTR2. So one is 2x raised to 3, 3x raised to 2. Which one is the greater term? It is 2x cubed. So we will write 2x cubed to the resultant polynomial. Then we understand that it is the end of that polynomial. One polynomial has finished. Now what is to be done? Once a polynomial is finished and the other one is still having terms, we just write down the terms of the remaining polynomial to the resultant polynomial. Then shift polynomial, write 3x square to the result, shift PTR2 to the next term, write 4x raised to 1 to the result, shift PTR2 to the next term of polynomial 2 and write 5x raised to 0, that is 5, to the resultant polynomial. That is the end of the addition operation. So if while comparing the exponents, if the exponents are equal, we have to add the coefficients. If the exponent of the first polynomial is greater than the exponent of the second polynomial, write the first polynomial to the result. Otherwise, write the second polynomial to the result. While one polynomial has completed and the other is having more terms, insert the remaining nodes to the resultant. So this is the algorithm on how to add polynomials using linked list. In this figure, you can see the resultant polynomial, which is also represented as a linked list. So here also we can identify that the nodes are inserted into the linked list in the order of descending order of their exponent fields. So this is about adding two polynomials by using linked list. Thank you. Next, we are going to learn how to multiply two polynomials. What do we mean by multiplication of two polynomials? In this procedure, each term of the first polynomial will be multiplied with each term of the second polynomial. Multiply means that we multiply the coefficients and add the exponents of the two terms. So, let us take one example. We have two polynomials. First one is represented as 4x cubed plus 3x square plus 1. Second polynomial is represented as 5x cubed plus 7x plus 5. Now, how to perform multiplication operation on them? So, for each term of the first polynomial, we must multiply with each term of the second polynomial. For each term of the first polynomial, we must multiply it with every term of the second polynomial. That means 4x cube will be multiplied with 5x cube, 7x and 5. Then we move to 3x square. Then we will multiply it with 5x cube, 7x and 5. Then we move to 1. Then we multiply it with 5x cube plus 7x plus 5. So the result will be 4 into 5 x raised to 3 plus 3 plus 4 into 7 x raised to 3 plus 1 plus 4 into 5 x raised to 3 plus 0 plus next 3 into 5 x raised to 2 plus 3 plus 3 into 7 x raised to 2 plus 1 plus 3 into 5 x raised to 2 plus 0 plus 1 into 5 x raised to 3 plus 0 plus 1 into 7 x raised to 0 plus 1 plus 1 into 5 x raised to 0 plus 0. This is how we calculate the result of multiplication. Now we are representing both the polynomials as using linked list. Then let poly 1 represent the first polynomial and poly 2 represent the second polynomial. Head 1 is the pointer to the first node of the first polynomial. Head 2 is the pointer to the first node of the second polynomial. To traverse through the first polynomial, we make a dummy pointer ptr1. To traverse through the second polynomial, we make a dummy pointer ptr2. So, in this algorithm, for each term of the first polynomial, we must multiply with every term of the second polynomial. So, we need a nested loop. Then, in the outer loop, we traverse through the terms of the first polynomial. In the inner loop, we will traverse through the second polynomial terms. So, while ptr1 not equal to null, within that, while ptr2 not equal to null, write some code. This is the general structure or base structure of the nested while loop we will be using. Because for each term of the first polynomial, we have to multiply it with every term of the second polynomial. So while ptr1 not equal to null, move to the next node. Shift ptr1 to the next node. So it will traverse until the first polynomial becomes empty, or until every node of that polynomial is being traversed. While ptr2 not equal to null, this loop will traverse through the second linked list, which stores the second polynomial until all the nodes are being traversed. So this is our code. We use two variables, result 1 and result 2, to store the intermediate results. Then for the resultant polynomial, let us assume that a pointer head 3 is pointing to the first node of the resultant polynomial. To traverse through the resultant polynomial, we may use a pointer ptr3. Then initially the resultant polynomial is empty. That is why we write struct node star head 3 is equal to null. While ptr1 not equal to null, that is, we are going to traverse in the outer loop. That is, we are going to traverse in the first polynomial. Within that, while we are at the first term of the first polynomial, point to the first node of the second polynomial first. Then ptr2 is equal to head 2. After that, make a while loop to traverse through each term of the second polynomial. That is, while ptr2 not equal to null, what is to be done? We must multiply the coefficients, add the exponents. So this is what we are doing for the intermediate results. That is, we are multiplying the coefficients and storing it in the intermediate result res1. We are adding the exponents and storing the result in res2. Now we call the insert function. We have seen this insert function in a previous lecture where we used the linked list to represent polynomial. There we have seen how we are inserting the coefficient value and exponent value, and how we created a new node and how we inserted that new node into a linked list. So that same insert function is used here to insert a new node in the descending order of their exponents. So this is the function head 3 is equal to insert. The arguments are head 3, res1 and res2, which means that head 3, it is the information about the resultant linked list. Head 3 is the pointer which points to the first node of the resultant linked list. If you know where is the first node located in a linked list, you can traverse the entire linked list, because that is the starting position. From the starting position, we are able to traverse through the entire linked list. So Passing head 3 into a function means that we are passing the linked list itself. And what is the return value? Return value is head 3 itself. That is the linked list, the updated linked list. That is the return value. Then PTR2 is equal to link of PTR. This statement is used to shift PTR2 to the next node of the second linked list. So using the inner while loop, we will traverse through all the nodes of the second linked list. After that, we have to shift the pointer PTR1 to the next node of the first linked list. That is PTR1 is equal to link of PTR1. After this, these entire steps, we will get the multiplication result in resultant polynomial, which is pointed by head 3. So in this case, PTR1 points to the first node, PTR point to the first node, or PTR2 points to the first node of the second linked list. So in the outer while loop, PTR1 is at the first node. Then in the inner while loop, PTR2, it traverses from first node, second node and third node of the second linked list. Once it has completed one iteration, PTR1 shifts to the next node. Then PTR2 will again start from first node of the second polynomial, move to the second node of the second polynomial and move to the third node of the second polynomial. Likewise, we will do this process until we complete the first polynomial. So this is how we perform polynomial multiplication with the help of linked list. Okay, thank you.